They just want to solve the problem, regardless of what the problem is.
So get out of their way, basically.
Get out of their way. Yeah.
Okay.
Don't impose your own ideas about how they should learn. And, this was the same thing as Rich Sutton put out in The Bitter Lesson, or Gurn put out in the Scaling Hypothesis. I think generally the dynamic was, I got this kind of inspiration from Ilya and from others, folks like Alec Radford, who did the original GPT-1, and then ran really hard with it. Me and my collaborators on GPT-2, GPT-3, RL from Human Feedback, which was an attempt to kind of deal with the early safety and steerability, things like debate and amplification, heavy on interpretability. So again, the combination of safety plus scaling, probably 2018, 2019, 2020, those were kind of the years when myself and my collaborators, probably many of whom became co-founders of Anthropic, kind of really had a vision and drove the direction.
Why'd you leave? Why'd you decide to leave?
Yeah. So look, I'm going to put things this way, and I think it ties to the race to the top, right? Which is, in my time at OpenAI, what I'd come to see as I'd come to appreciate the scaling hypothesis, and as I'd come to appreciate kind of the importance of safety along with the scaling hypothesis. The first one, I think, OpenAI was getting on board with. The second one, in a way, had always been part of OpenAI's messaging. But over many years of the time that I spent there, I think I had a particular vision of how we should handle these things, how we should be brought out in the world, the kind of principles that the organization should have. And look, I mean, there were many, many discussions about should the company do this? Should the company do that? There's a bunch of misinformation out there. People say we left because we didn't like the deal with Microsoft. False. Although, there was a lot of discussion, a lot of questions about exactly how we do the deal with Microsoft. We left because we didn't like commercialization. That's not true. We built GPT-3, which was the model that was commercialized. I was involved in commercialization. It's more, again, about how do you do it? Civilization is going down this path to very powerful AI. What's the way to do it that is cautious, straightforward, honest, that builds trust in the organization and in individuals? How do we get from here to there? And how do we have a real vision for how to get it right? How can safety not just be something we say because it helps with recruiting? I think at the end of the day, if you have a vision for that, forget about anyone else's vision. I don't want to talk about anyone else's vision. If you have a vision for how to do it, you should go off and you should do that vision. Mm-hmm. It is incredibly unproductive to try and argue with someone else's vision. You might think they're not doing it the right way. You might think they're dishonest. Who knows? Maybe you're right. Maybe you're not. But what you should do is you should take some people you trust and you should go off together and you should make your vision happen. And if your vision is compelling, if you can make it appeal to people, some combination of ethically, in the market, if you can make a company that's a place people want to join, that, engages in practices that people think are reasonable while managing to maintain its position in the ecosystem at the same time. If you do that, people will copy it. And the fact that you are doing it, especially the fact that you're doing it better than they are, causes them to change their behavior in a much more compelling way than if they're your boss and you're arguing with them. I don't know how to be any more specific about it than that, but I think it's generally very unproductive to try and get someone else's vision to look like your vision. It's much more productive to go off and do a clean experiment and say, this is our vision. This is how we're going to do things. Your choice is you can ignore us, you can reject what we're doing, or you can start to become more like us. And imitation is the sincerest form of flattery. And that plays out in the behavior of customers, that plays out in the behavior of the public, that plays out in the behavior of where people choose to work. And again, at the end, it's not about one company winning or another company winning. If we or another company are engaging in some practice that, people find genuinely appealing, and I want it to be in substance, not just in appearance. I think researchers are sophisticated and they look at substance. and then other companies start copying that practice and they win because they copied that practice, that's great. That's success. That's like the race to the top. It doesn't matter who wins in the end, as long as everyone is copying everyone else's good practices, right? One way I think of it is like the thing we're all afraid of is the race to the bottom, right? And the race to the bottom doesn't matter who wins because we all lose, right? Like, in the most extreme world, we make this autonomous AI that, the robots enslave us or whatever, right? I mean, that's half joking, but that is the most extreme thing that could happen. Then it doesn't matter which company was ahead. If instead you create a race to the top where people are competing to engage in good practices, then at the end of the day, it doesn't matter who ends up winning. It doesn't even matter who started the race to the top. The point isn't to be virtuous. The point is to get the system into a better equilibrium than it was before. And individual companies can play some role in doing this. Individual companies can help to start it, can help to accelerate it. And frankly, I think individuals at other companies have done this as well, right? The individuals that when we put out an RSP react by pushing harder to get something similar done at other companies. Sometimes other companies do something that's like, we're like, oh, it's a good practice. We think that's good. We should adopt it too. The only difference is, I think we are, we try to be more forward leaning. We try and adopt more of these practices first and adopt them more quickly when others invent them. But I think this dynamic is what we should be pointing at. And that I think it abstracts away the question of, which company's winning, who trusts who. I think all these questions of drama are profoundly uninteresting. And the thing that matters is the ecosystem that we all operate in and how to make that ecosystem better, because that constrains all the players.
And so Anthropic is this kind of clean experiment built on a foundation of like what concretely AI safety should look like.
I'm sure we've made plenty of mistakes along the way. The perfect organization doesn't exist. It has to deal with the imperfection of 1,000 employees. It has to deal with the imperfection of our leaders, including me. It has to deal with the imperfection of the people we've put to oversee the imperfection of the leaders, like the board and the long-term benefit trust. It's all a set of imperfect people trying to aim imperfectly at some ideal that will never perfectly be achieved. That's what you sign up for. That's what it will always be. But imperfect doesn't mean you just give up. There's better and there's worse. And hopefully we can begin to build, we can do well enough that we can begin to build some practices that the whole industry engages in. And then, my guess is that multiple of these companies will be successful. Anthropic will be successful. These other companies, like ones I've been at in the past, will also be successful. And some will be more successful than others. That's less important than, again, that we align the incentives of the industry. And that happens partly through the race to the top, partly through things like RSP, partly through, again, selected surgical regulation.
You said talent density beats talent mass. So can you explain that? Can you expand on that? Can you just talk about what it takes to build a great team of AI researchers and engineers?
This is one of these statements that's like more true every month. Every month I see this statement as more true than I did the month before. So if I were to do a thought experiment, let's say you have a team of 100 people that are super smart, motivated, and aligned with the mission, and that's your company. Or you can have a team of 1,000 people where 200 people are super smart, super aligned with the mission, and then like 800 people are, let's just say you pick 800 like random big tech employees. Which would you rather have, right? The talent mass is greater in the group of 1,000 people, right? You have even a larger number of incredibly talented, incredibly aligned, incredibly smart people. But the issue is just that if every time someone super talented looks around, they see someone else super talented and super dedicated, that sets the tone for everything, right? That sets the tone for everyone is super inspired to work at the same place. Everyone trusts everyone else. If you have 1,000 or 10,000 people and things have really regressed, right? You are not able to do selection and you're choosing random people. What happens is then you need to put a lot of processes and a lot of guardrails in place. Just because people don't fully trust each other, you have to adjudicate political battles. Like there are so many things that slow down the org's ability to operate. And so we're nearly 1,000 people. And, we've tried to make it so that as large a fraction of those 1,000 people as possible are like super talented, super skilled. It's one of the reasons we've slowed down hiring a lot in the last few months. We grew from 300 to 800, I think, in the first 7-8 months of the year. And now we've slowed down. We're at the last 3 months, we went from 800 to 900, 950, something like that. Don't quote me on the exact numbers, but I think there's an inflection point around 1,000, and we want to be much more careful how we grow. Early on, and now as well, we've hired a lot of physicists. Theoretical physicists can learn things really fast. Even more recently, as we've continued to hire that, we've really had a high bar on both the research side and the software engineering side, have hired a lot of senior people, including folks who used to be at other companies in this space. And we've just continued to be very selective. It's very easy to go from 100 to 1,000 and 1,000 to 10,000 without paying attention to making sure everyone has a unified purpose. It's so powerful. If your company consists of a lot of different fiefdoms that all want to do their own thing, they're all optimizing for their own thing, it's very hard to get anything done. But if everyone sees the broader purpose of the company, if there's trust and there's dedication to doing the right thing, that is a superpower. That in itself, I think, can overcome almost every other disadvantage.
And, it's the Steve Jobs A players. A players want to look around and see other A players, is another way of saying
Correct.
that. I don't know what that is about human nature, but it is demotivating to see people who are not obsessively driving towards a singular mission. And it is, on the flip side of that, super motivating to see that. It's interesting. What's it take to be a great AI researcher or engineer from everything you've seen, from working with so many amazing people?
Yeah. I think the number one quality, especially on the research side, but really both, is open-mindedness. Sounds easy to be open-minded, right? You're just like, oh, I'm open to anything. But if I think about my own early history in the scaling hypothesis, I was seeing the same data others were seeing. I don't think I was like a better programmer or better at coming up with research ideas than any of the hundreds of people that I worked with. In some ways I was worse. I've never precise programming of finding the bug, writing the GPU kernels. Like I could point you to 100 people here who are better at that than I am. But the thing that I think I did have that was different was that I was just willing to look at something with new eyes, right? People said, oh, we don't have the right algorithms yet. We haven't come up with the right way to do things. And I was just like, oh, I don't know. This neural net has 30 million parameters. Like, what if we gave it 50 million instead? Let's plot some graphs. That basic scientific mindset of oh man, I see some variable that I could change. What happens when it changes? Let's try these different things and create a graph. For even this was the simplest thing in the world, right? Change the number of, this wasn't PhD level experimental design. This was simple and stupid. Anyone could have done this if you just told them that it was important. It's also not hard to understand. You didn't need to be brilliant to come up with this. But you put the two things together and some tiny number of people, some single digit number of people have driven forward the whole field by realizing this. And it's, it's often like that. If you look back at the discoveries in history, they're often like that. And so this open-mindedness and this willingness to see with new eyes that often comes from being newer to the field, often experience is a disadvantage for this. That is the most important thing. It's very hard to look for and test for, but I think it's the most important thing, because when you find some really new way of thinking about things, when you have the initiative to do that, it's absolutely transformative.
And also be able to do kind of rapid experimentation, and in the face of that, be open-minded and curious and looking at the data with just these fresh eyes and seeing what is that it's actually saying. That applies in mechanistic interpretability.
It's another example of this. Some of the early work in mechanistic interpretability, so simple. It's just no one thought to care about this question before.
You said what it takes to be a great AI researcher. Can we rewind the clock back? what advice would you give to people interested in AI? They're young, looking forward. How can I make an impact on the world?
I think my number one piece of advice is to just start playing with the models. Yeah. This was actually, I worry a little. This seems like obvious advice now. I think 3 years ago, it wasn't obvious, and people started by, let me read the latest reinforcement learning paper. Let me kind of, no, I mean, that was really and I mean, you should do that as well. But now, with wider availability of models and APIs, people are doing this more. But I think just experiential knowledge. These models are new artifacts that no one really understands. And so getting experience playing with them. I would also say, again, in line with the do something new, think in some new direction. There are all these things that haven't been explored. For example, mechanistic interpretability is still very new. It's probably better to work on that than it is to work on new model architectures because it's more popular than it was before. There are probably 100 people working on it, but there aren't 10,000 people working on it. And it's this fertile area for study. There's so much low hanging fruit. You can just walk by and you can pick things. And the only reason, for whatever reason, people aren't interested in it enough. I think there are some things around long horizon learning and long horizon tasks where there's a lot to be done. I think evaluations we're still very early in our ability to study evaluations, particularly for dynamic systems acting in the world. I think there's some stuff around multi-agent. Skate where the puck is going is my advice. And you don't have to be brilliant to think of it. All the things that are going to be exciting in 5 years, in people even mention them as conventional wisdom, but it's just somehow there's this barrier that people don't double down as much as they could, or they're afraid to do something that's not the popular thing. I don't know why it happens, but getting over that barrier is my number one piece of advice.
Let's talk, if we could, a bit about post-training.
Yeah.
So it seems that the modern post-training recipe has a little bit of everything. So supervised fine-tuning, RLHF, the constitutional AI with RLAIF.
Best acronym.
It's again that naming thing. And then synthetic data. Seems like a lot of synthetic data, or at least trying to figure out ways to have high quality synthetic data. So what's the if this is a secret sauce that makes Anthropic Claude so incredible? How much of the magic is in the pre-training? How much of it is in the post-training?
Yeah, so first of all, we're not perfectly able to measure that ourselves. Sure. When you see some great character ability, sometimes it's hard to tell whether it came from pre-training or post-training. We've developed ways to try and distinguish between those two, but they're not perfect. The second thing I would say is, it's when there is an advantage, and I think we've been pretty good at in general at RL, perhaps the best, although I don't know because I don't see what goes on inside other companies. Usually it isn't, oh my God, we have this secret magic method that others don't have, right? Usually it's we got better at the infrastructure so we could run it for longer, or, we were able to get higher quality data, or we were able to filter our data better, or we were able to, combine these methods in practice. It's usually some boring matter of kind of practice and tradecraft. So, when I think about how to do something special in terms of how we train these models, both pre-training, but even more so post-training, I really think of it a little more, again, as designing airplanes or cars. It's not just oh man, I have the blueprint. Maybe that makes you make the next airplane, but there's some cultural tradecraft of how we think about the design process that I think is more important than any particular gizmo we're able to invent.
Okay, well, let me ask you about specific techniques. So first on RLHF, what do you think, just zooming out, intuition, almost philosophy, why do you think RLHF works so well?
If I go back to the scaling hypothesis, one of the ways to skate the scaling hypothesis is if you train for X and you throw enough compute at it, then you get X. And so RLHF is good at doing what humans want the model to do, or at least to state it more precisely, doing what humans who look at the model for a brief period of time and consider different possible responses, what they prefer as the response, which is not perfect from both a safety and capabilities perspective, in that humans are often not able to perfectly identify what the model wants, and what humans want in the moment may not be what they want in the long term. So there's a lot of subtlety there, but the models are good at producing what the humans in some shallow sense want. And it actually turns out that you don't even have to throw that much compute at it because of another thing, which is this thing about a strong pre-trained model being halfway to anywhere. So once you have the pre-trained model, you have all the representations you need to get the model where you want it to go.
So do you think our RLHF makes the model smarter or just appears smarter to the humans?
I don't think it makes the model smarter. I don't think it just makes the model appear smarter. It's like RLHF bridges the gap between the human and the model, right? I could have something really smart that can't communicate at all, right? We all know people like this, people who are really smart, but you can't understand what they're saying. So I think RLHF just bridges that gap. I think it's not the only kind of RL we do. It's not the only kind of RL that will happen in the future. I think RL has the potential to make models smarter, to make them reason better, to make them operate better, to make them develop new skills even. Mm-hmm. And perhaps that could be done, even in some cases with human feedback. But the kind of RLHF we do today mostly doesn't do that yet, although we're very quickly starting to be able to.
But it appears to sort of increase, if you look at the metric of helpfulness, it increases that.
It also increases, what was this word in Leopold's essay, unhobbling, where basically the models are hobbled and then you do various trainings to them to unhobble them. Yeah. So I like that word because it's like a rare word, but so I think RLHF unhobbles the models in some ways. And then there are other ways where a model hasn't yet been unhobbled and needs to unhobble.
If you can say, in terms of cost, is pre-training the most expensive thing, or is post-training creep up to that?
At the present moment, it is still the case that pre-training is the majority of the cost. I don't know what to expect in the future, but I could certainly anticipate a future where post-training is the majority of the cost.
In that future you anticipate, would it be the humans or the AI that's the costly thing for the post-training?
I don't think you can scale up humans enough to get high quality. Any kind of method that relies on humans and uses a large amount of compute, it's going to have to rely on some scaled supervision method, like debate or iterated amplification or something like that.
So on that, it's a super interesting set of ideas around constitutional AI. Can you describe what it is, as first detailed in December 2022 paper, and beyond that, what is it?
Yes. So this was from 2 years ago. The basic idea is, so we describe what RLHF is. You have a model, and it spits out you just sample from it twice. It spits out two possible responses, and you're like, human, which response do you like better? Or another variant of it is rate this response on a scale of 1 to 7. So that's hard because you need to scale up human interaction, and it's very implicit, right? I don't have a sense of what I want the model to do. I just have a sense of what this average of 1,000 humans wants the model to do. So two ideas. One is, could the AI system itself decide which response is better, right? Could you show the AI system these two responses and ask which response is better? And then second, well, what criterion should the AI use? And so then there's this idea, could you have a single document, a constitution, if you will, that says these are the principles the model should be using to respond? And the AI system reads those it reads those principles as well as reading the environment and the response. And it says, well, how good did the AI model do? It's basically a form of self-play. You're kind of training the model against itself. And so the AI gives the response, and then you feed that back into what's called the preference model, which in turn feeds the model to make it better. So you have this triangle of the AI, the preference model, and the improvement of the AI itself.
And we should say that in the Constitution, the set of principles are human interpretable. They're
it's something both the human and the AI system can read. So it has this nice kind of translatability or symmetry. in practice, we both use a model constitution and we use RLHF and we use some of these other methods. So it's turned into one tool in a toolkit that both reduces the need for RLHF and increases the value we get from using each data point of RLHF. It also interacts in interesting ways with kind of future reasoning type RL methods. So it's one tool in the toolkit, but I think it is a very important tool.
Well, it's a compelling one to us humans, thinking about the founding fathers and the founding of the United States. The natural question is, who and how do you think it gets to define the Constitution, the set of principles in the Constitution?
Yeah, so I'll give like a practical answer and a more abstract answer. I think the practical answer is like, look, in practice, models get used by all kinds of different like customers, right? And so you can have this idea where the model can have specialized rules or principles. We fine tune versions of models implicitly. We've talked about doing it explicitly, having special principles that people can build into the models. So from a practical perspective, the answer can be very different from different people. Customer service agent, behaves very differently from a lawyer and obeys different principles. But I think at the base of it, there are specific principles that models, have to obey. I think a lot of them are things that people would agree with. Everyone agrees that, we don't want models to present these CBRN risks. I think we can go a little further and agree with some basic principles of democracy and the rule of law. Beyond that, it gets, very uncertain. And there our goal is generally for the models to be more neutral, to not espouse a particular point of view and, more just be kind of like wise agents or advisors that will help you think things through and will, present possible considerations, but, don't express, strong or specific opinions.
OpenAI released a model spec where it kind of clearly, concretely defines some of the goals of the model and specific examples like A, B, how the model should behave. Do you find that interesting? By the way, I should mention I believe the brilliant John Schulman was a part of that. He's now at Anthropic. Do you think this is a useful direction? Might Anthropic release a model spec as well?
Yeah, so I think that's a pretty useful direction. Again, it has a lot in common with constitutional AI. So again, another example of like a race to the top, right? We have something that's like, we think, a better and more responsible way of doing things. It's also a competitive advantage. Then others kind of, discover that it has advantages and then start to do that thing. We then no longer have the competitive advantage, but it's good from the perspective that now everyone has adopted a positive practice that others were not adopting. And so our response to that is, well, looks like we need a new competitive advantage in order to keep driving this race upwards. So that's how I generally feel about that. I also think every implementation of these things is different. So, there were some things in the model spec that were not in constitutional AI. And so, we can always adopt those things or, at least learn from them. So again, I think this is an example of like the positive dynamic that I think we should all want the field to have.
Let's talk about the incredible essay, Machines of Love and Grace. I recommend everybody read it. It's a long one.
It is rather long.
Yeah. It's really refreshing to read concrete ideas about what a positive future looks like. And you took sort of a bold stance because like it's very possible that you might be wrong on the dates or the specific applications.
Oh yeah, I'm fully expecting to, will definitely be wrong about all the details. I might be just spectacularly wrong about the whole thing, and people will laugh at me for years. That's just how the future works.
So you provided a bunch of concrete positive impacts of AI and how, exactly a super intelligent AI might accelerate the rate of breakthroughs in, for example, biology and chemistry that would then lead to things like we cure most cancers, prevent all infectious disease, double the human lifespan, and so on. So let's talk about this essay. First, can you give a high-level vision of this essay and what key takeaways that people should have?
Yeah, I have spent a lot of time, and Anthropic has spent a lot of effort on like, how do we address the risks of AI, right? How do we think about those risks? Like we're trying to do a race to the top, what that requires us to build all these capabilities, and the capabilities are cool, but we're like a big part of what we're trying to do is like address the risks. And the justification for that is like, well, all these positive things, the market is this very healthy organism, right? It's going to produce all the positive things. The risks, I don't know. We might mitigate them, we might not. And so we can have more impact by trying to mitigate the risks. But I noticed that one flaw in that way of thinking, and it's not a change in how seriously I take the risks, it's maybe a change in how I talk about them, is that, no matter how kind of logical or rational that line of reasoning that I just gave might be, if you kind of only talk about risks, your brain only thinks about risks. And so I think it's actually very important to understand, what if things do go well? And the whole reason we're trying to prevent these risks is not because we're afraid of technology, not because we want to slow it down. It's because if we can get to the other side of these risks, right? If we can run the gauntlet successfully, to put it in stark terms, then on the other side of the gauntlet are all these great things, and these things are worth fighting for, and these things can really inspire people. And I think I imagine, because look, you have all these investors, all these VCs, all these AI companies talking about all the positive benefits of AI, but as you point out, it's weird. There's actually a dearth of really getting specific about it. There's a lot of random people on Twitter posting these kind of gleaming cities and this just kind of vibe of grind, accelerate harder, kick out the decel. It's just this very aggressive, ideological. But then you're like, well, what are you? What are you actually excited about? Yeah. And so I figured that, I think it would be interesting and valuable for someone who's actually coming from the risk side to try and really make a try at explaining what the benefits are. Both because I think it's something we can all get behind, and I want people to understand. I want them to really understand that this isn't doomers versus accelerationists. This is that if you have a true understanding of where things are going with AI, and maybe that's the more important axis, AI is moving fast versus AI is not moving fast, then you really appreciate the benefits, and you want humanity, our civilization, to seize those benefits, but you also get very serious about anything that could derail them.
So I think the starting point is to talk about what this powerful AI, which is the term you like to use. Most of the world uses AGI, but you don't like the term because it's basically has too much baggage. It's become meaningless. It's we're stuck with the terms, whether we like them or not.
Maybe we're stuck with the terms, and my efforts to change them are futile.
It's admirable.
I'll tell you what else I don't. This is a pointless semantic point, but I keep talking about it
Back
in public,
to naming
so I'm just
again.
I'm just gonna do it once more. I think it's a little like let's say it was 1995 and Moore's law is making the computers faster, and for some reason there had been this verbal tick that everyone was well, someday we're going to have supercomputers, and supercomputers are going to be able to do all these things that once we have supercomputers, we'll be able to sequence the genome, we'll be able to do other things. And so one, it's true, the computers are getting faster, and as they get faster, they're going to be able to do all these great things. But there's no discrete point at which you had a supercomputer and previous computers were not. Supercomputer is a term we use, but it's a vague term to just describe computers that are faster than what we have today. There's no point at which you pass the threshold and you're oh my God, we're doing a totally new type of computation and new. And so I feel that way about AGI. There's just a smooth exponential. And if by AGI, you mean AI is getting better and better, and gradually it's going to do more and more of what humans do until it's going to be smarter than humans, and then it's going to get smarter even from there, then yes, I believe in AGI. If AGI is some discrete or separate thing, which is the way people often talk about it, then it's kind of a meaningless buzzword.
Yeah, I mean, to me, it's just sort of a platonic form of a powerful AI, exactly how you define it. I mean, you define it very nicely. So on the intelligence axis, it's just on pure intelligence, it's smarter than a Nobel Prize winner, as you describe, across most relevant disciplines. So, okay, that's just intelligence. So it's both in creativity and be able to generate new ideas, all that kind of stuff. In every discipline, Nobel Prize winner. Okay, in their prime. It can use every modality. So that's kind of self-explanatory, but just operate across all the modalities of the world. It can go off for many hours, days, and weeks to do tasks and do its own sort of detailed planning and only ask you help when it's needed. It can use, this is actually kind of interesting. I think in the essay you said, I mean, again, it's a bet that it's not going to be embodied, but it can control embodied tools. So it can control tools, robots, laboratory equipment. The resource used to train it can then be repurposed to run millions of copies of it. And each of those copies would be independent, that can do their own independent work. So you can do the cloning of the intelligence system.
Yeah. I mean, you might imagine from outside the field that like there's only one of these, right? That like you made it, you've only made one. But the truth is that like the scale up is very quick. Like we do this today. We make a model and then we deploy thousands, maybe tens of thousands of instances of it. I think by the time, certainly within 2 to 3 years, whether we have these super powerful AIs or not, clusters are going to get to the size where you'll be able to deploy millions of these, and they'll be, faster than humans. And so if your picture is, we'll have one and then it'll take a while to make them, my point there was, no, actually you have millions of them right away.
And in general, they can learn and act 10 to 100 times faster than humans. So that's a really nice definition of powerful AI. Okay, so that, but you also write that clearly such an entity would be capable of solving very difficult problems very fast, but it is not trivial to figure out how fast. Two extreme positions both seem false to me. So the singularity is on the one extreme and the opposite on the other extreme. Can you describe each of the extremes?
Yeah.
And why?
So yeah, let's describe the extreme. So like one extreme would be, well, look, if we look at kind of evolutionary history, like there was this big acceleration where, for hundreds of thousands of years, we just had like, single-celled organisms, and then we had mammals, and then we had apes, and then that quickly turned to humans. Humans quickly built industrial civilization. And so this is going to keep speeding up, and there's no ceiling at the human level. Once models get much, much smarter than humans, they'll get really good at building the next models. And, if you write down like a simple differential equation, like this is an exponential. And so what's going to happen is that models will build faster models will build faster models, and those models will build, nanobots that can like take over the world and produce much more energy than you could produce otherwise. And so if you just kind of like solve this abstract differential equation, then like 5 days after we build the first AI that's more powerful than humans, then like the world will be filled with these AIs, and every possible technology that could be invented, like will be invented. I'm caricaturing this a little bit. But I think that's one extreme. And the reason that I think that's not the case is that, one, I think they just neglect like the laws of physics. Like it's only possible to do things so fast in the physical world. Like some of those loops go through, producing faster hardware. It takes a long time to produce faster hardware. Things take a long time. There's this issue of complexity. Like I think no matter how smart you are, like, people talk about, we can make models of biological systems that'll do everything the biological systems. Look, I think computational modeling can do a lot. I did a lot of computational modeling when I worked in biology, but like just there are a lot of things that you can't predict how they're complex enough that like just iterating, just running the experiment is going to beat any modeling, no matter how smart the system doing the modeling is.
Or even if it's not interacting with the physical world, just the modeling is going to be hard.
Yeah, I think, the modeling is going to be hard, and getting the model to match the physical world is going to be hard.
All right, so he does have to interact with the physical world to verify.
But it's just, you just look at even the simplest problems. Like, I think I talk about like, the 3-body problem or simple chaotic prediction, like, or like predicting the economy. It's really hard to predict the economy 2 years out. Like maybe the case is like, normal, humans can predict what's going to happen in the economy in the next quarter, although they can't really do that. Maybe a AI system that's, a zillion times smarter can only predict it out a year or something instead of you have these kind of exponential increase in computer intelligence for linear increase in ability to predict. Same with, again, like, biological molecules interacting. You don't know what's going to happen when you perturb a complex system. You can find simple parts in it. If you're smarter, you're better at finding these simple parts. And then I think human institutions are really difficult. Like it's been hard to get people. I won't give specific examples, but it's been hard to get people to adopt even the technologies that we've developed, even ones where the case for their efficacy is very, very strong. People have concerns. They think things are conspiracy theories. Like it's been very difficult. It's also been very difficult to get, very simple things through the regulatory system, right? I think, I don't want to disparage anyone who, works in regulatory systems of any technology. There are hard trade-offs they have to deal with. They have to save lives. But the system as a whole, I think, makes some obvious trade-offs that are very far from maximizing human welfare. And so if we bring AI systems into this, into these human systems, often the level of intelligence may just not be the limiting factor, right? It just may be that it takes a long time to do something. Now, if the AI system circumvented all governments, if it just said, I'm dictator of the world and I'm going to do whatever, some of these things it could do. Again, the things having to do with complexity, I still think a lot of things would take a while. I don't think it helps that the AI systems can produce a lot of energy or go to the moon. Like some people in comments responded to the essay saying the AI system can produce a lot of energy and smarter AI systems. That's missing the point. That kind of cycle doesn't solve the key problems that I'm talking about here. So I think a bunch of people missed the point there. But even if it were completely unaligned and, could get around all these human obstacles, it would have trouble. But again, if you want this to be an AI system that doesn't take over the world, that doesn't destroy humanity, then basically, it's going to need to follow basic human laws, right? If we want to have an actually good world, like we're going to have an AI system that interacts with humans, not one that kind of creates its own legal system or disregards all the laws or all of that. So as inefficient as these processes are, we're going to have to deal with them because there needs to be some popular and democratic legitimacy in how these systems are rolled out. We can't have a small group of people who are developing these systems say this is what's best for everyone, right? I think it's wrong, and I think in practice it's not going to work anyway. So you put all those things together, and we're not gonna change the world and upload everyone in 5 minutes. I don't think it. I don't think it's going to happen, and B, to the extent that it could happen, it's not the way to lead to a good world. So that's on one side. On the other side, there's another set of perspectives which I have actually in some ways more sympathy for, which is, look, we've seen big productivity increases before, right? Economists are familiar with studying the productivity increases that came from the computer revolution and the internet revolution. And generally, those productivity increases were underwhelming. They were less than you might imagine. There was a quote from Robert Solow: "You see the computer revolution everywhere except the productivity statistics." So why is this the case? People point to the structure of firms, the structure of enterprises, how slow it's been to roll out our existing technology to very poor parts of the world, which I talk about in the essay, right? How do we get these technologies to the poorest parts of the world that are behind on cell phone technology, computers, medicine, let alone, newfangled AI that hasn't been invented yet? So you could have a perspective that's like, well, this is amazing technically, but it's all a nothing burger. I think Tyler Cowen, who wrote something in response to my essay, has that perspective. I think he thinks the radical change will happen eventually, but he thinks it'll take 50 or 100 years. And you could have even more static perspectives on the whole thing. I think there's some truth to it. I think the time scale is just too long. And I can see it. I can actually see both sides with today's AI. So, a lot of our customers are large enterprises who are used to doing things a certain way. I've also seen it in talking to governments, right? Those are prototypical, institutions, entities that are slow to change. But the dynamic I see over and over again is, yes, it takes a long time to move the ship. Yes, there's a lot of resistance and lack of understanding. But the thing that makes me feel that progress will in the end happen moderately fast, not incredibly fast, but moderately fast, is that you talk to, what I find over and over again, in large companies, even in governments, which have been actually surprisingly forward-leaning, you find two things that move things forward. One, you find a small fraction of people within a company, within a government, who really see the big picture, who see the whole scaling hypothesis, who understand where AI is going, or at least understand where it's going within their industry. And there are a few people like that within the current US government who really see the whole picture. And those people see that this is the most important thing in the world until they agitate for it. And the thing, they alone are not enough to succeed because they're a small set of people within a large organization. But as the technology starts to roll out, as it succeeds in some places, in the folks who are most willing to adopt it, the specter of competition gives them a wind at their backs because they can point within their large organization. They can say, look, these other guys are doing this, right? One bank can say, look, this newfangled hedge fund is doing this thing. They're going to eat our lunch. In the US, we can say, we're afraid China's going to get there before we are. And that combination, the specter of competition, plus a few visionaries within these, the organizations that in many ways are sclerotic, you put those two things together and it actually makes something happen. I mean, it's interesting. It's a balanced fight between the two because inertia is very powerful. But eventually, over enough time, the innovative approach breaks through. And I've seen that happen. I've seen the arc of that over and over again. And it's like the barriers are there. The barriers to progress, the complexity, not knowing how to use the model, how to deploy them are there. And for a bit, it seems like they're going to last forever, like change doesn't happen. But then eventually change happens and always comes from a few people. I felt the same way when I was an advocate of the scaling hypothesis within the AI field itself and others didn't get it. It felt like no one would ever get it. It felt like we had a secret almost no one ever had. And then a couple years later, everyone has the secret. And so I think that's how it's going to go with deployment to AI in the world. It's going to, the barriers are going to fall apart gradually and then all at once. And so I think this is going to be more, and this is just an instinct. I could easily see how I'm wrong. I think it's going to be more like 5 or 10 years, as I say in the essay, then it's going to be 50 or 100 years. I also think it's going to be 5 or 10 years more than it's going to be, 5 or 10 hours, because I've just seen how human systems work. And I think a lot of these people who write down these differential equations, who say AI is going to make more powerful AI, who can't understand how it could possibly be the case that these things won't change so fast, I think they don't understand these things.
So what do you use the timeline to where we achieve AGI, aka powerful AI, aka super useful AI?
I'm going to start calling it that.
It's a debate about naming. On pure intelligence, it can smarter than a Nobel Prize winner in every relevant discipline and all the things we've said. Modality, it can go and do stuff on its own for days, weeks, and do biology experiments on its own. You know what? Let's just stick to biology because you sold me on the whole biology and health section. That's so exciting I was getting giddy from a scientific perspective. It made me want to be a biologist.
This was the feeling I had when I was writing it, that it's like, this would be such a beautiful future if we can just make it happen, right? If we can just get the landmines out of the way and make it happen. There's so much beauty and elegance and moral force behind it. If we can just, and it's something we should all be able to agree on, right? Like, as much as we fight about all these political questions, is this something that could actually bring us together? But you were asking when will we get this?
When do you think? What's just put numbers on?
So this is of course the thing I've been grappling with for many years, and I'm not at all confident. Every time if I say 2026 or 2027, there will be like a zillion like people on Twitter who will be like, AI CEO said 2026, 2020, and it'll be repeated for like the next 2 years that like this is definitely when I think it's going to happen. So whoever's excerpting these clips will crop out the thing I just said and only say the thing I'm about to say. But I'll just say it anyway.
Have fun with
it. So if you extrapolate the curves that we've had so far, right? If you say, well, I don't know, we're starting to get to like PhD level, and last year we were at undergraduate level, and the year before we were at like the level of a high school student. Again, you can quibble with at what tasks and for what, we're still missing modalities, but those are being added. Like computer use was added, like image was added, like image generation has been added. If you just kind of like, and this is totally unscientific, but if you just kind of like eyeball the rate at which these capabilities are increasing, it does make you think that we'll get there by 2026 or 2027. Again, lots of things could derail it. We could run out of data. We might not be able to scale clusters as much as we want. Like, maybe Taiwan gets blown up or something, and, then we can't produce as many GPUs as we want. So there are all kinds of things that could derail the whole process. So I don't fully believe the straight line extrapolation. But if you believe the straight line extrapolation, we'll get there in 2026 or 2027. I think the most likely is that there's some mild delay relative to that. I don't know what that delay is, but I think it could happen on schedule. I think there could be a mild delay. I think there are still worlds where it doesn't happen in 100 years. The number of those worlds is rapidly decreasing. We are rapidly running out of truly convincing brocklers, truly compelling reasons why this will not happen in the next few years. There were a lot more in 2020. Although my guess, my hunch at that time was that we'll make it through all those blockers. So sitting as someone who has seen most of the blockers cleared out of the way, I kind of suspect, my hunch, my suspicion is that the rest of them will not block us. But look at the end of the day, like, I don't want to represent this as a scientific prediction. People call them scaling laws. That's a misnomer. Like Moore's law is a misnomer. Moore's law, scaling laws, they're not laws of the universe. They're empirical regularities. I am going to bet in favor of them continuing, but I'm not certain of that.
So you extensively describe sort of the compressed 21st century, how AGI will help set forth a chain of breakthroughs in biology and medicine that help us in all these kinds of ways that I mentioned. So how do you think, what are the early steps it might do? And by the way, I asked Claude good questions to ask you. And Claude told me to ask, what do you think is a typical day for a biologist working on AGI look like in this future?
Yeah.
Claude is curious.
Let me start with your first questions, and then I'll answer that. Claude wants to know what's in its future, right?
Exactly.
Who am I going to be working with?
Exactly.
So I think one of the things I went hard on in the essay is, let me go back to this idea of, because it's really had an impact on me. This idea that within large organizations and systems, there end up being a few people or a few new ideas who kind of cause things to go in a different direction they would have before, who kind of disproportionately affect the trajectory. There's a bunch of kind of the same thing going on, right? If you think about the health world, there's like, trillions of dollars to pay out Medicare and, other health insurance. And then the NIH is $100 billion. And then if I think of like the few things that have really revolutionized anything, it could be encapsulated in a small fraction of that. And so when I think of like, where will AI have an impact? I'm like, can AI turn that small fraction into a much larger fraction and raise its quality? And within biology, my experience within biology is that the biggest problem of biology is that you can't see what's going on. You have very little ability to see what's going on, and even less ability to change it, right? What you have is this, like from this, you have to infer that there's a bunch of cells, that within each cell is, 3 billion base pairs of DNA built according to a genetic code. And there are all these processes that are just going on without any ability of us as, unaugmented humans to affect it. These cells are dividing. Most of the time that's healthy, but sometimes that process goes wrong, and that's cancer. The cells are aging. Your skin may change color, develops wrinkles as you age. And all of this is determined by these processes, all these proteins being produced, transported to various parts of the cells, binding to each other. And in our initial state about biology, we didn't even know that these cells existed. We had to invent microscopes to observe the cells. We had to invent more powerful microscopes to see, below the level of the cell to the level of molecules. We had to invent X-ray crystallography to see the DNA. We had to invent gene sequencing to read the DNA. Now, we had to invent protein folding technology to predict how it would fold and how they bind and how these things bind to each other. we had to invent various techniques for now we can edit the DNA as of, with CRISPR as of the last 12 years. So the whole history of biology, a whole big part of the history is basically our ability to read and understand what's going on and our ability to reach in and selectively change things. And my view is that there's so much more we can still do there, right? You can do CRISPR, but you can do it for your whole body. Let's say I want to do it for one particular type of cell and I want the rate of targeting the wrong cell to be very low. That's still a challenge. That's still things people are working on. That's what we might need for gene therapy for certain diseases. And so the reason I'm saying all of this, and it goes beyond, beyond this to, to gene sequencing, to new types of nanomaterials for observing what's going on inside cells, for, antibody drug conjugates. The reason I'm saying all this is that this could be a leverage point for the AI systems, right? That the number of such inventions, it's in the mid double digits or something, mid double digits, maybe low triple digits over the history of biology. Let's say I have 1 million of these AIs, can they discover 1,000, working together, can they discover thousands of these very quickly? And does that provide a huge lever instead of trying to leverage the, $2 trillion a year we spend on, Medicare or whatever? Can we leverage the 1 billion a year that's spent to discover, but with much higher quality? And so what is it like, being a scientist that works with an AI system? The way I think about it actually is, so I think in the early stages, the AIs are going to be like grad students. You're going to give them a project. You're going to say, I'm the experienced biologist. I've set up the lab. The biology professor or even the grad students themselves will say, here's what you can do with an AI, AI system. I'd like to study this. And, the AI system, it has all the tools. It can look up all the literature to decide what to do. It can look at all the equipment. It can go to a website and say, hey, I'm going to go to, Thermo Fisher or, whatever the lab equipment company is, dominant lab equipment company is today. In my time, it was Thermo Fisher. I'm going to order this new equipment to do this. I'm going to run my experiments. I'm going to, write up a report about my experiments. I'm going to, inspect the images for contamination. I'm going to decide what the next experiment is. I'm going to write some code and run a statistical analysis. All the things a grad student would do, there will be a computer with an AI that the professor talks to every once in a while, and it says, this is what you're going to do today. The AI system comes to it with questions. When it's necessary to run the lab equipment, it may be limited in some ways. It may have to hire a human lab assistant to do the experiment and explain how to do it. Or it could use advances in lab automation that are gradually have been developed over the last decade or so, and will continue to be developed. And so it'll look like there's a human professor and 1,000 AI grad students. And, if you go to one of these Nobel Prize winning biologists or so, you'll say, okay, well, you had 50 grad students. Well, now you have 1,000, and they're smarter than you are, by the way. Then I think at some point it'll flip around where the AI systems will be the PIs, will be the leaders, and they'll be ordering humans or other AI systems around. So I think that's how it'll work on the research side.
And they would be the inventors of a CRISPR type technology.
They would be the inventors of a CRISPR type technology. And then I think, as I say in the essay, we'll want to turn probably turning loose is the wrong term, but we'll want to harness the AI systems to improve the clinical trial system as well. There's some amount of this that's regulatory, that's a matter of societal decisions, and that'll be harder. But can we get better at predicting the results of clinical trials? Can we get better at statistical design so that clinical trials that used to require 5,000 people and therefore needed $100 million in a year to enroll them, now they need 500 people in 2 months to enroll them? That's where we should start. And can we increase the success rate of clinical trials by doing things in animal trials that we used to do in clinical trials and doing things in simulations that we used to do in animal trials? Again, we won't be able to simulate it all. AI is not God. But can we shift the curve substantially and radically? So I don't know. That would be my picture.
Doing it in vitro and doing it, I mean, you're still slowed down. It still takes time, but you can do it much, much faster.
Yeah. Can we just one step at a time? And can that add up to a lot of steps? Even though we still need clinical trials, even though we still need laws, even though the FDA and other organizations will still not be perfect, can we just move everything in a positive direction? And when you add up all those positive directions, do you get everything that was going to happen from here to 2100 instead happens from 2027 to 2032 or something?
Another way that I think the world might be changing with AI, even today, but moving towards this future of the powerful, super useful AI, is programming. So how do you see the nature of programming? Because it's so intimate to the actual act of building AI. How do you see that changing for us humans?
I think that's going to be one of the areas that changes fastest for two reasons. One, programming is a skill that's very close to the actual building of the AI. So the farther a skill is from the people who are building the AI, the longer it's going to take to get disrupted by the AI, right? Like, I truly believe that like AI will disrupt agriculture. Maybe it already has in some ways, but that's just very distant from the folks who are building AI. And so I think it's going to take longer. But programming is the bread and butter of, a large fraction of the employees who work at Anthropic and at the other companies. And so it's going to happen fast. The other reason it's going to happen fast is with programming, you close the loop, both when you're training the model and when you're applying the model. The idea that the model can write the code means that the model can then run the code and then see the results and interpret it back. And so it really has an ability, unlike hardware, unlike biology, which we just discussed, the model has an ability to close the loop. And so I think those two things are going to lead to the model getting good at programming very fast. As I saw on, typical real world programming tasks, models have gone from 3% in January of this year to 50% in October of this year. So, we're on that S curve, right? Where it's going to start slowing down soon because you can only get to 100%. But I would guess that in another 10 months, we'll probably get pretty close. We'll be at least 90%. So again, I would guess, I don't know how long it'll take, but I would guess again, 2026, 2027, Twitter people who crop out who crop out these numbers and get rid of the caveats, like I don't know, I don't like you, go away. I would guess that the kind of task that the vast majority of coders do, AI can probably, if we make the task very narrow, like just write code, AI systems will be able to do that. Now, that said, I think comparative advantage is powerful. We'll find that when AIs can do 80% of a coder's job, including most of it that's literally like write code with a given spec, we'll find that the remaining parts of the job become more leveraged for humans, right? They'll be more about like high-level system design or, looking at the app and like, is it architected well? And the design and UX aspects. And eventually AI will be able to do those as well, right? That's my vision of the, powerful AI system. But I think for much longer than we might expect, we will see that small parts of the job that humans still do will expand to fill their entire job in order for the overall productivity to go up. That's something we've seen. It used to be that, writing and editing letters was very difficult, and like writing the print was difficult. Well, as soon as you had word processors and then computers, and it became easy to produce work and easy to share it, then that became instant, and all the focus was on the ideas. So this logic of comparative advantage that expands tiny parts of the tasks to large parts of the tasks and creates new tasks in order to expand productivity, I think that's going to be the case. Again, someday AI will be better at everything, and that logic won't apply. And then we all have, humanity will have to think about how to collectively deal with that, and we're thinking about that every day. And that's another one of the grand problems to deal with, aside from misuse and autonomy. And we should take it very seriously. But I think in the near term, and maybe even in the medium term, like 2, 3, 4 years, I expect that humans will continue to have a huge role, and the nature of programming will change. But programming as a role, programming as a job will not change. It'll just be less writing things line by line, and it'll be more macroscopic.
And I wonder what the future of IDEs looks like. So the tooling of interacting with AI systems, this is true for programming and also probably true for in other contexts, like computer use, but maybe domain specific. Like we mentioned biology, it probably needs its own tooling about how to be effective. And then programming needs its own tooling. Is Anthropic going to play in that space of also tooling potentially?
I'm absolutely convinced that powerful IDEs, that there's so much low-hanging fruit to be grabbed there. That, right now it's just like you talk to the model and it talks back. But look, I mean, IDs are great at kind of lots of static analysis of so much is possible with kind of static analysis, like many bugs you can find without even writing the code. Then, IDs are good for running particular things, organizing your code, measuring coverage of unit tests. Like there's so much that's been possible with the normal IDs. Now you add something like, well, the model now, the model can now like write code and run code. Like I am absolutely convinced that over the next year or two, even if the quality of the models didn't improve, that there would be enormous opportunity to enhance people's productivity by catching a bunch of mistakes, doing a bunch of grunt work for people, and that we haven't even scratched the surface. Anthropic itself, I mean, you can't say, no, it's hard to say what will happen in the future. Currently, we're not trying to make such IDs ourselves. Rather, we're powering the companies like Cursor or like Cognition or some of the other, Expo in the security space, others that I can mention as well that are building such things themselves on top of our API. And our view has been, let 1,000 flowers bloom. We don't internally have the resources to try all of these different things. Let's let our customers try it. And we'll see who succeeds, and maybe different customers will succeed in different ways. So I both think this is super promising, and it's not something, Anthropic isn't eager to at least right now compete with all our companies in this space, and maybe never.
Yeah, it's been interesting to watch Cursor try to integrate Claude successfully because it's actually fascinating how many places it can help the programming experience. It's not as trivial.
It is really astounding. I feel like, as a CEO, I don't get to program that much. And I feel like if 6 months from now I go back, it'll be completely unrecognizable to me.
Exactly. So in this world with super powerful AI that's increasingly automated, what's the source of meaning for us humans?
Yeah.
Work is a source of deep meaning for many of us. So where do we find the meaning?
This is something that I've written about a little bit in the essay, although I give it a bit short shrift, not for any principled reason, but this essay, if you believe it, was originally going to be 2 or 3 pages. I was going to talk about it at all hands, and the reason I realized it was an important, underexplored topic is that I just kept writing things, and I was just like, oh man, I can't do this justice, and so the thing ballooned to like 40 or 50 pages, and then when I got to the work and meaning section, I'm like, oh man, this isn't going to be 100 pages. Like I'm going to have to write a whole other essay about that. But meaning is actually interesting because you think about like the life that someone lives or something, or like, let's say you were to put me in like a simulated environment or something where like, like I have a job and I'm trying to accomplish things, and I don't know, I like do that for 60 years. And then you're like, oh, like, oops, this was actually all a game, right? Does that really kind of rob you of the meaning of the whole thing? Like I still made important choices, including moral choices. I still sacrificed. I still had to kind of gain all these skills, or just like a similar exercise, think back to like, one of the historical figures who, discovered electromagnetism or relativity or something. If you told them, well, actually 20,000 years ago, some alien on this planet discovered this before you did. Does that rob the meaning of the discovery? It doesn't really seem like it to me, right? It seems like the process is what matters, and how it shows who you are as a person along the way. And, how you relate to other people and like the decisions that you make along the way, those are consequential. I could imagine if we handle things badly in an AI world, we could set things up where people don't have any long-term source of meaning or any, but that's that's more a set of choices we make. That's more a set of the architecture of a society with these powerful models. If we design it badly and for shallow things, then that might happen. I would also say that, most people's lives today, while admirably, they work very hard to find meaning in those lives. Like, look, we who are privileged and who are developing these technologies, we should have empathy for people, not just here, but in the rest of the world, who spend a lot of their time kind of scraping by to like survive. Assuming we can distribute the benefits of this technology to everywhere, like their lives are going to get a hell of a lot better. Meaning will be important to them as it is important to them now. But we should not forget the importance of that, and that. The idea of meaning as kind of the only important thing is in some ways an artifact of a small subset of people who have been economically fortunate. But I think all that said, I think a world is possible with powerful AI that not only has as much meaning for everyone, but that has more meaning for everyone, right? That can allow everyone to see worlds and experiences that it was either possible for no one to see or possible for very few people to experience. So I am optimistic about meaning. I worry about economics and the concentration of power. That's actually what I worry about more. I worry about how do we make sure that fair world reaches everyone. When things have gone wrong for humans, they've often gone wrong because humans mistreat other humans. That is maybe in some ways even more than the autonomous risk of AI or the question of meaning. That is the thing I worry about most. The concentration of power, the abuse of power, structures like autocracies and dictatorships where a small number of people exploits a large number of people. I'm very worried about that.
And AI increases the amount of power in the world, and if you concentrate that power and abuse that power, it can do immeasurable damage.
Yes, it's very frightening. It's very frightening.
Well, I highly encourage people to read the full essay. That should probably be a book or a sequence of essays, because it does paint a very specific future. And I could tell the later sections got shorter and shorter because you started to probably realize that this is going to be a very long essay.
One, I realized it would be very long, and two, I'm very aware of and very much try to avoid, just being, I don't know what the term for it is, but one of these people who's kind of overconfident and has an opinion on everything and kind of says a bunch of stuff and isn't an expert. I very much tried to avoid that, but I have to admit, once I got the biology sections, like I wasn't an expert. And so as much as I expressed uncertainty, probably I said a bunch of things that were embarrassing or wrong.
Well, I was excited for the future you painted, and thank you so much for working hard to build that future. And thank you for talking today, Dario.
Thanks for having me. I just hope we can get it right and make it real. And if there's one message I wanna send, it's that to get all this stuff right, to make it real, we both need to build the technology, build the companies, the economy around using this technology positively. But we also need to address the risks because those risks are in our way. They're landmines on the way from here to there. And we have to diffuse those landmines if we want to get there.
It's a balance like all things in life.
Like all things.
Thank you.